Greeting everyone. Today we will present our innovation. The name is the development of an application to inspect sweet young coconut meat to identify the estimated harvest period. My name is Thaksin Kaungsa.
And my name is Thirapat Pipat Bunyarat.
For the first slide, we will talk about the introduction. In January, we will use the hand to see the coconut is ready to eat or not. So it uses a lot of time. It makes the market demand don't interested and middlemen as well too. But on the other hand, if you use the technology, you will less the time to check the coconut. So it's make interesting on the market demand and middlemen. So you can make more money from that as well. We will process the coconut layers by RGB, SSV color and pattern of coconut. So we will use two of these to code for our application to estimating the harvest time and measuring the color of the coconut bottle. And then you will see the coconuts ready to be collected or not. So this slide is about the framework. So we use Python for our base language for our application and use the library and modules and then use the image documentation. So it means you have one information, but you can make many information that is similar. And then we will use the library cost entropy to consider the information is good or not. And then we will make the graph with the underfitting and overfitting of the DL model. So we will use the balance graph because you can see the trend of the information. But if the graph will be the underfitting or overfitting, you cannot see the trend because if we have the new information, that information we cannot see the trend, so it's not work. So we will use three of these with the deep learning to analyze the information, and then we will use the Hugging Face for our host application. And then we will use API to set the data to our phone and our application created by React Native and Expo.
The next section is the findings. We have two different versions of the model. First, the bare model contains a 2D convolution layer to accept images as input and max pooling 2D to extract valuable information from the images. Then use pattern to reduce from 2 dimensions to 1 dimension, so the dense layer can accept its input. And the last layer is the activation function to produce the desired output. And the second is with the drop-off layer, which is randomly sets input unit to 0 with a frequency of rate at each step during training time, which helps prevent overfitting. Next is rectified linear activation function, which is easier to train and often achieve better performance. And the last one is normalization, which helps to generalize the data to be more usable for the model. We take a look at the bare model's error graph. We can see that the validation error in the orange line is higher than the training error in the blue line. It indicates that the model is overfitting. But in another version, the validation error is lower than the training error, so we can assume that the model is working fine. With the addition of the recall and precision value is high. In the real test, we have 25 images labeled as ready and 25 images labeled as not ready for a total of 50 images. Our model can predict 80% of ready images and 68% of not ready correctly. So the overall categorizing accuracy is 73.5%. And for mobile application users, it can send the image data to the API, and the API sends the result back and display it to the user. In conclusions, the best model for classifying coconut that is ready and not ready to be collected consists of convolutional 2D, max pooling 2D, activation, batch normalization, dropout, pattern, and dust layer with an overall accuracy of 73.5% and is suitable for mobile application. And here is our references.
Thank you.